This is a GATE 2010 question in physics. This is question number 43, which is completely based on the Maxwell's relation. As you can see that the question states that which among the following sets of Maxwell relations is correct, where U is the internal energy, H is the enthalpy, A is the Helmholtz free energy, and G is the Gibbs free energy. So what are those internal energy, enthalpy, how it is defined in terms of basic thermodynamic parameters, that we will see, and from there we try to find out these relationships, and we will see that out of all these four options which one will be the correct option. So to go ahead, we start with, so U is the internal energy as defined in the question, H is the enthalpy as defined, Gibbs free energy is G, and Helmholtz free energy is A. Now how it is defined actually in terms of thermodynamic variables like entropy, like temperature, internal energy, and pressure and volume. So these are the basic, that is particularly T, V, and P. Along with that you have S and U. Based on these five variables, generally this H, G, and A are defined. So the first equation which I have written is for the enthalpy. H is equal to U, the internal energy, plus P times V, pressure into volume. G is the Gibbs free energy, which is defined as U plus PV minus TS. And A, the Helmholtz free energy, is defined as U minus TS. So these are the definitions based on the thermodynamic variables. On the other hand, we also know that from the first law of thermodynamics, that is TdS is equal to du plus PdV. Now what is this TdS? This TdS is nothing but delta Q. TdS is nothing but the amount of heat change into the system. So TdS is equal to du plus PdV. Now based on that, if now we try to find out what will be the temperature, then what we have to do is that we have to put it in that constant volume, because at constant volume PdV will be 0. So it will be du by ds, or delta U delta S, whatever. So T is equal to delta U delta S at constant volume. Whereas to find out the pressure, this pressure, if we need to find out that, then P will be equal to minus delta U delta V at constant S, because at constant S this TdS will be 0, kind of an adiabatic process, and from there we get du by dV with a negative sign. So these are two relations which we can directly derive from the first law of thermodynamics. Now from equation 1, which is for the enthalpy, we differentiate both sides. dH will be equal to du plus PdV plus VdP, because U plus PV was there, so it will be du plus PdV plus VdP. dH, now from first law of thermodynamics, like this expression from first law of thermodynamics, this du is nothing but what? TdS minus PdV. So we can write it as TdS minus PdV. Along with that we have plus PdV, along with that we have plus VdP. Now this PdV and PdV cancels out, therefore DH can be written as TdS plus VdP. So this is the expression which we have got. From there what we can say? We can find out temperature as well as volume relations from this particular expression. So what will be the temperature? So to find out the temperature, we have to fix the pressure. So pressure should be constant, therefore VdP term will be 0, this term will be 0, pressure is constant, therefore we have dH by ds. So delta H by delta S at constant pressure can be written as temperature from this particular expression. To find out volume, we have to fix the entropy, therefore at constant entropy we have dH by dP. So this becomes the volume. So from the enthalpy expression, if we differentiate and find out temperature and volume, this comes out to be the relations. From equation 3, that is for Helmholtz free energy, A is equal to U minus Ts, we differentiate both sides again like we have done for the equation 1. So it will be dA is equal to du minus TdS minus SdT. Therefore dA will be equal to, now this du again I replace it from first law of thermodynamics, and we get TdS minus PdV. Minus TdS minus SdT was there, so TdS cancels here. We get dA is equal to minus PdV minus SdT. Now what all thermodynamical variables are there here? P and S, which we can find out based on the derivatives. So P becomes dA by dV or delta A by delta V with a negative sign at constant temperature, because if we fix the temperature then only we can find out P. Otherwise we cannot. Therefore we fix the temperature, and for T is equal to constant we get this kind of an expression. And for S we have to fix V, so at constant volume it will be delta A by delta T with a minus sign. So these are the relations which we have got from the, by differentiating both sides for the Helmholtz free energy. And the last is the Gibbs free energy. From equation 2 we see that G is equal to U plus PV minus TS, and we just differentiate as we have done for the earlier cases. So dG will be equal to du plus pdv plus vdp minus tds minus sdt. All possible terms we have written, and again we will replace du with tds minus pdv. So now minus pdv and this plus pdv cancels out, tds and minus tds cancels out, we get vdp minus sdt as dg. Now what all thermodynamical variables we have? V and S, which we can find out based on the some kind of a derivative function. And for volume we have to fix the temperature, so this term will be 0 if we fix the temperature, so it will be dg by dp at constant temperature. And for entropy we have to fix pressure, so at constant pressure we have minus dg by dt as S. So these are the following expressions which we have got. Now it seems that from the question or the options which are given, so if we compare all those things, what we can see is that T is equal to delta U delta V at constant S, P is equal to delta U delta S at constant V. Let's see which one is matching. Delta U delta S at constant V, P is minus delta U by delta V at constant S. So yeah, so this term we have P is equal to delta U by delta S. No, but here it is exactly opposite, so it is not the expression which we are looking at. Next is T is equal to delta H by delta S at constant P. Let's see, T is equal to delta H by delta S at constant P. No, where it is given delta S at constant P. Yes, this is given here. And now we have to check that V is equal to delta H by delta P at constant S. V is equal to delta H by delta P at constant S. Therefore this is the correct option which we are getting as B. So only this option is given. Other options if you check, then these parameters does not satisfy whatever we have got. Therefore the B is the correct option for this particular problem. So B is the correct option. Thank you.